All right, guys, today we are going to be solving quadratic equations by factoring, okay? So the last few times we have been solving quadratics without us even knowing. I have been asking you to put it back into a factor instead of keeping the solution, okay? So recall that a linear equation is an equation whose largest exponent is 1. For example, 2x plus 5 equals 13. The equation has one solution. Okay, so the one solution that it is when we solve it, we're going to subtract 5. We have 2x equals 8, because 13 minus 5 is 8. Then divide by 2, x equals 4. It has one solution, okay? Whereas if it's a quadratic equation, is an equation whose largest exponent is 3. For example, we have 2x squared plus 5x equals 13. This equation has two solutions. How do we find them? The quadratic equation can be solved using the zero factor principle. The solutions to the quadratic equations are the x-intercepts of the equation. We've talked about that before. Setting each factor equal to 0 allows us to find the solutions, which are also called the x-intercept. So solution, x-intercept, and these are often always called zeros or roots. So if you see solutions, zeros, roots, or x-intercept, those are all asking the same thing. Okay, so these are the same thing. Okay, so steps to solving a quadratic function by factoring. So if it's in root form, meaning that it already gives you the factors. That's factor number 1. This is factor number 2. You set each factor to 0 and solve or use railroads. So for example, right now, this is a quadratic. We don't know that though off the just top of the head, but we want to solve for what n could be. And there's two factors here. So this is factor number 1 and this is factor number 2. So in order to solve this quadratic, I would set each factor equal to 0 and solve for n. So we're going to add 4 here, and then 3n equals 4, divide by 3. N equals 4 over 3. This one over here, we're going to subtract 5. 3n equals negative 5. Divide by 3. N equals negative 5 over 3. And these are the solutions, the roots. Okay. What if it gives it to you in standard form? So the x squared plus x minus 2, okay? Look for the greatest common factor, which is first step always. Factor them. Set each factor equal to 0, then solve. Okay, so that would be the rule if I didn't already teach you the calculator trick. So if our quadratic is already in, or is in our standard form. So standard form being, it's an x squared plus x minus a number, okay? It's not in the factor form, in root form, okay, where it gives us both of our factors. When it's in x squared, we can just do menu 331 here. So when you do menu 331, A2 gets a 1, A1 gets a 3, and A0 gets a negative 28. When you do this, your solutions end up being negative 7 and 4. Okay, because I want the solutions, the roots, the x-intercepts, whatever it is, whatever I call it, okay, you do not have to put it in a factor because I want the solutions. Okay, we talked about how solutions and factors are two totally different things. A solution is what x truly equals. A factor is the two binomials that get us the trinomial. Okay, so if I'm in factor form right now because I want the solution, I set each of them equal to 0 and solve for the variable. If it's in quadratic form, I use menu 331. Okay, so I'm going to allow you to do number 3 and 4 on your own. You're going to check your answers. All right, so this one and this one, you have to determine, is it in our root form, meaning it gives us the factors, or is it in standard form? Does it give it to us in 2x squared plus 5x minus 3? Okay, that will determine what you do on each problem. Okay, and then number 5 is an application problem. We worked on this yesterday. Okay, so again, you're going to do 3 through 4 on your own and check it with my answers.